name is Kate. I have not been to this meetup before. This is a version of a talk that I gave for the iOS developer meetup. So my background is definitely more development than DevOps, but I'll do my best. What I'm going to do is I'm going to give you a little bit of context around what my company does so that you can better understand the solution. So bear with me at the beginning, but it will get technical after that. And yeah, I guess we'll get started. Oh no, now it's not working. Oh, there we go. So did you know that 1 in 100 babies have an inherited genetic disorder when they're born? And most people who are carriers of genetic disorders show no symptoms. So 2 healthy parents can have a child with an inherited genetic disease. All right, I'll just do it this way. So meet EUGENE. So my company is EUGENE. I'm the CTO. So we provide at-home genetic testing that enables people to make smart decisions about their health. Our tests are diagnostic grade, which means that they can be used by doctors to help you make a health plan. And through our app, you get access to a compassionate and caring health team. So what is EUGENE, technically speaking? Well, EUGENE is an iOS app, it's an Android app, it's a web app, and we also have a bunch of services underneath. So we have a patient management system where we store our patient data and genetic counselling appointments. We have a content management system for all of our content around genetic conditions and advice and results for patients. We have a secure video calling service, a survey platform for taking medical histories, and then we have the shopping cart, the logistics of shipping testing kits out to people, as well as notifications and alerts. So how do we build the system? So our key considerations are security. Because most of our customers are on mobile apps, we also need to reduce the number of requests we make and reduce the amount of data transmitted to save battery and to save time. We also need to provide offline support, particularly around when patients are uploading their medical history. You don't want to be in the middle of providing that and then lose all the information you've entered. As well as just in general having less code means less bugs. So we have some options to build this system. So we could use a bunch of third-party SDKs and frameworks. So our content management system has an SDK, our patient management system has an API, so we could build a framework around that. Our video calling service has an SDK. We could definitely do that. But with 3 different platforms, this is going to be a lot of repeated code. We could create client-specific REST APIs. So what I mean by that is a REST API for each platform that will make our services consumable by that platform and optimized for that platform. So depending on what we show on a certain screen in Android, we can create a REST endpoint for that screen, and it will talk to all our services underneath. Or we can look at GraphQL. So that's what we've done. And then our other consideration was offline data. So there's a few options for that as well. So in the mobile space, you can embed a database, which is going to be a copy of the database that's on the server. So Realm and Couchbase are examples of databases for mobile that do this. They replicate the data locally and on the server as you call it down. But AppSync has this ability as well. And then we also have an option. We could just say, no, just be online. So this is what EUGENE looks like. So we have our local data store that's provided by AppSync. We have our single GraphQL endpoint, and we have all of our services underneath. Now, it's not really this neat, but close enough. So what is AppSync? So AppSync is managed GraphQL integrated with AWS services. So you create your GraphQL schema, you connect to data sources, which can be AWS services and HTTP endpoints, etc. And then AppSync provides the real-time data and offline services through an SDK on the client side. Who knows much about GraphQL? A few hands, not a lot. Okay. So GraphQL, it's an API. It's a specification for an API, so it's implemented in a lot of different languages. You can get lots of libraries that implement the specification. And what the specification describes is that you create a schema for your data that's typed. So you always know what a GraphQL API, what data it can provide. It's self-documenting, which I'll show you in a minute. And then the client is able to run queries against that schema. So the client can say, I want this specific field from this specific query and this data only. And then the GraphQL API will go and fetch that data from the services underneath and will return it to the client. So just for a little bit of where did this come from, here's some companies that use GraphQL in production right now. So would you like to see a demo of GraphQL running? We're running a little bit over time, but I can, okay? All right, let's do that. All right, so can you see that? I can zoom in a bit. Yeah, so I said it was self-documenting. This is GraphQL, which is a graphic user interface that you can get for GraphQL servers. And if you go into docs here, you can see everything that's available to you. And this will run on any GraphQL server. So you can just download this library and run it. So I can see that I can do some queries. Here's all my queries that I can run. So this particular API is a Star Wars information API. So I can get all films, all persons, all planets, all species. Here's all the attributes that I can pass in to customize that query. And so if I take this for an example, this will return an array of species. What's a species? Well, I can click on it and now I can see all this information. So it makes your APIs very, very easy to use for new people joining your team. And so we have an example over here. So this is running the Starship query. It's asking for the Starship name Millennium Falcon. From that query, it wants the name, the hyperdrive rating, and then the pilots, and pilots is also able to have attributes passed in. And so I can delete any of these and make a custom query for whatever my client requires. So, and here's the output here. So if I was to say, oh, I really just care about their names, I don't care about this stuff, I can just delete those, and this time it will return the name. So that's the power of GraphQL, particularly for mobile platforms where we care about the amount of requests and the amount of data that's passing back and forth. So how does this work in AppSync? So that schema, the documentation that I showed you, that's the GraphQL schema. You put that in AppSync and then you have to connect that to what we call resolvers. So resolvers is where the data is actually fetched from. So a resolver can be an existing HTTP endpoint. So if you have existing REST APIs and you just want to get them more efficient for a mobile app, you can just put them behind a GraphQL API. There's no problem with doing that. And then there's also AWS services that it's integrated with. So Lambda and DynamoDB have been around for a while as resolver options. But they've just added RDS, Elasticsearch, and I think maybe one or two others. Pipeline resolvers is also new, which is a way of stringing together resolvers, which is really great because it just adds a bit more options when you have complex examples to run with. So this is a diagram of what I'm trying to say. So the GraphQL request comes in, we then have a request template that you can use to transform that request into something to then pass to your data source. So for example, if you have an existing REST API, you can manipulate the arguments that have been passed into your GraphQL API to be into a format that your REST API can understand. So you don't necessarily need a Lambda in between your GraphQL request and your existing endpoints. You can just pass the information straight through. And then it'll come back from the REST API where you have another option to manipulate that data back into the format that the GraphQL response expects, and then it'll get passed back out. So this is an example of the mapping template that I just described. So here we're getting the arguments from our GraphQL query, and we're basically just putting them into a JSON payload to pass to a GraphQL, a REST API or a Lambda function. And yeah, we're passing some other information as well. So there's a lot of flexibility that you can have there. And then, so AppSync allows you to have real-time data. So it supports that through the SDK, and using the GraphQL specification allows for real-time data subscriptions. It's not as amazing as it sounds, so it does have a few limitations. So I would only use it for data that is frequently updating. So if you've got data that perhaps you just want to check, like every time someone visits a certain screen or something, don't use this. This is just for stuff that's kind of changing constantly. And then another limitation is that it will only notify you if that data has changed from someone calling a mutation on the GraphQL API. So a mutation is, I guess, like the equivalent of like a post or something. It's a change that's being requested. So if the data changes underneath, there's no way of sending that through unless you have sort of a dummy mutation that you're able to call to tell the API that that has changed. And yet underneath it's implemented over WebSockets. So offline, that's mostly implemented on the client side as well. So basically the SDK gives you the option to have an optimistic UI. So you write code as if you're expecting a response, and that will be executed. And then when you get the response back, if it's different to what you expected, then you handle that change. This is built on the Apollo library, which Apollo is a GraphQL implementation. And most of AppSync, I think, uses Apollo under the hood. The cache also will store local changes and then upload them when you're reconnected. The docs talk about basic and customizable conflict resolution. I put an asterisk there because I've not actually found the documentation that says how to do this. So I believe it's a feature, I'm just not sure. I think maybe it only works on DynamoDB resolvers and that's it, but not sure. So there's a couple of bonus features you get as well using AppSync. So there's code generation that will create classes and libraries and things. I mean, not libraries, but the classes and the data structures that you need on the client-side code. So it'll keep the client side and the server side in sync, as well as IDE tools for Xcode and things like that. So in terms of deploying AppSync, you can use Amplify. Has anyone used Amplify? Do you know much about Amplify? Yeah. So I guess my opinion of Amplify is that it's kind of AWS for mobile developers that don't know anything about backend systems. So I have attempted to use it and I've had to abandon it because pretty much immediately our use of GraphQL was more than it could handle. So I think it's improving. They have just released being able to have different environments, which I was confused about why they would have released it in the first place without that. But that's positive. I think maybe 6 months to a year, I might come back to it and see whether it can now do the things that I need. But yeah, other than for simple projects, I'd probably steer clear of Amplify. The AppSync console is fine if you want to get up and running, but really you want to use CloudFormation if you want any kind of repeatable environment. All the docs are going to direct you to Amplify, but yeah. So I guess my opinion of AppSync is that it's really good for new projects. It definitely helps you keep all of your web services organized and behind one endpoint, which is really, really nice. Existing projects, look, if you've already found solutions for offline, if you've found solutions for real-time that are working for you, I'm not sure there's enough here for a new project, but they're adding new things all the time. So the addition of pipeline resolvers was welcome, as well as, yeah, the other kinds of resolvers as well. So I would keep an eye on it. Originally, when I gave this talk in maybe November, I said no for existing projects, and now like, oh yeah, it's getting there. So that's the end of my talk. If you want to ask me any questions, you can find me on Twitter. EUGENE, we're a poor little startup, but if you're interested in greenfield projects and have a bit of spare time, please hit me up, and we're welcome, for anyone who wants any freelance work or anything. And if you're interested in finding out more about your productive risk if you're planning a family, please visit our website and check out our test. Thank you.
Cool. Any questions? Yep.
Can we use GraphQL for the existing APIs, or is it just for the new APIs?
No, so if you have an existing API, you can put GraphQL in front of that. Mm-hmm. So you can pass your REST APIs through a GraphQL endpoint. You can just talk directly to those, like if you've got Lambda functions, you can talk directly to them through the GraphQL API. So what I mean is, when I say just new projects, I mean like if you're thinking about a new architecture, like something completely fresh with a mobile app, then I would definitely consider it. If you've got an existing project and your mobile app isn't too complicated, then probably you could still consider it. If your mobile app has been around for a while, they've probably already found solutions to a bunch of these problems, and that's where I'm not sure it's worthwhile. But yeah, I would not say that you can't use it with existing APIs. I guess it's more existing clients that I would have a concern about.
So, but if we have, let's say, an API which can result one item at a time,
yeah,
and you do a query to list all the items, so does it, how the GraphQL, does it like hit the API with all the data endpoints, all the items, iterate through, and how does it work?
Yeah, so you have an API that returns one item,
yeah,
and you want to use GraphQL to return all items.
Yeah.
Yeah, so GraphQL is going to hit that API to get all the items,
so
right?
Is there like a performance issue?
Like, that's, yeah, that wouldn't really make sense. Like, you would have to make a new, if you want to get all the items, mm-hmm. you can make a new endpoint and point GraphQL at that, or you can point GraphQL directly to your database or whatever. But no, it can't, well, it can, but it would kill your performance. So yeah, you wouldn't do it that way.
Okay.
Yeah.
Thanks.
Any more questions, guys? Oh.
Based on the experience you've had with GraphQL, would it be worth looking at something like Neptune, which is doing the actual GraphDB with the GraphQL interface in front of it already? Would that have an influence on your project in the short term, long term?
I mean, there isn't a direct, like you would have to go through Lambda or something to make that connection. They don't offer a Neptune resolver direct. So I would probably, like our data doesn't have that many levels deep, right? If you had a lot, possibly. But for us, I think the benefits of DynamoDB, so DynamoDB and AppSync have been working together for a while now, so that integration is quite optimized. So I would probably stick with that, knowing our data. But if that wasn't working, if that was quite slow, then yes, you could put a Lambda and then talk to Neptune and do it that way if that gave you better performance.
Cool, thanks.
Yeah.
Is that it?